All right, for 200 years, a core idea in math was basically set in stone. It was a hard limit on what we thought we could ever solve. But what if that wall, that mathematical law everyone accepted, just got a huge crack in it?
I mean, seriously, what if a problem that everyone, and I mean everyone, called impossible for 2 centuries just got solved? The whole thing revolves around something called a polynomial equation, and for the longest time we believed some of them were just unsolvable. Well, this is the story of how that belief might have just been completely shattered.
Okay, so first things first, what even is a polynomial equation? Let's keep it simple. Think of it like a really complex recipe. You've got your variables, which are your ingredients, and then you have your instructions, add this, multiply that. The whole goal is to find the perfect amount of your ingredients, the exact values, that makes the final dish, the whole equation, equal 0. For simple recipes, that's a piece of cake, but for others, well, that's where our story really kicks off.
Right, so for centuries, this was one of the biggest challenges in algebra: how to find the exact solution for these super high-degree equations. Some are pretty straightforward, yeah? But as they get more and more complex, what mathematicians call a higher degree, they were considered unsolvable. And I don't just mean hard, I mean literally fundamentally impossible to crack with a single general formula. And here's the wall they hit. For any equation that was degree 5 or higher, the entire world of mathematics just kind of gave up. They operated under this core belief that you simply could not find a general formula to get an exact answer. Sure, you could get close with approximations, but a perfect, precise symbolic solution, that was considered pure fantasy. So where did this whole idea of impossible even come from? I mean, it wasn't just a guess, right? Nope. It came from a super powerful theorem that, for all intents and purposes, built a giant brick wall right in the middle of mathematics. And that wall? It's been standing for almost 200 years. Let's just take a quick trip back in time to see how this all played out. For a while there, we were on a roll. We're talking ancient times. Mathematicians solved quadratic or degree 2 equations. Fast forward to the 16th century and, boom, we cracked cubic and quartic equations. That's degrees 3 and 4. The progress was undeniable. And then, 1824, everything came to a screeching halt. And this is why. Abel's impossibility theorem. This theorem flat out stated that there is no general algebraic solution for polynomial equations of degree 5 or higher if you're only using a finite number of simple operations, adding, multiplying, taking roots. For generations of mathematicians, this wasn't just a theory, it was gospel. So yeah, this one belief totally defined the limits of algebra. It set the boundaries for what was even possible, until now. And that's the pivot. That's the whole reason we're talking about this today.
So, let's meet our challenger. This is Professor Mourad Sultan Ezouidi, and he has come forward with a claim that is, well, it's absolutely groundbreaking. He's not just chipping away at that 200-year-old wall, he's claiming he can knock the whole thing down. What he's saying is this: he's developed a brand new method, which he calls Ezouidi's theorem, that delivers the exact symbolic solutions for these high-degree polynomials. The very same ones Abel's theorem said were impossible to solve? We're not talking about getting close. We're talking about perfect, 100% verifiable algebraic answers. And he's not just talking theory. To back it up, his work lays out a complete and exact solution for an 8th-degree polynomial. Let that sink in. An 8th-degree polynomial. That's a feat that has been considered flat-out impossible under the classical rules for 2 centuries. This isn't just a step forward. It's a giant leap. There's a great quote from him that just perfectly captures the whole spirit of this thing. He says, "But limits exist only until they are surpassed." I mean, wow. That's the mindset it takes to challenge one of the longest-standing assumptions in all of mathematics. Okay, so you're probably wondering, how is this even possible? What's the fundamental difference between the old way of thinking and this radical new approach? Well, it really boils down to a clash of philosophies, a battle between old tools and new ones. And this is what I find so fascinating. It's about the mindset. The classical approach, the one that's been around since Mourad Abel, basically, accepted defeat. It said, okay, for these high-degree equations, the best we can do is get an approximate numerical answer. But Ezouidi's approach, it completely rejects that. It refuses to settle for close enough and instead goes all in, pursuing 100% algebraic precision to find the exact answer. This table really lays it all out, doesn't it? The classical methods following Abel and another mathematician named Galois just declared anything over the 4th degree impossible to solve exactly.
Ezouidi's theorem says, nope, we can get exact symbolic solutions. One side depends on approximations, the other is 100% algebraic and verifiable. It's a total shift in philosophy, from accepting limits to what Ezouidi calls rejecting mathematical fatalism. One preserves old boundaries, the other wants to establish a whole new paradigm.
So how in the world does this method actually work? Well, let's think about it conceptually. Instead of just trying the old keys that everyone knows won't work, Ezouidi's method is like a master locksmith. First, it reorganizes the structure of the polynomial, breaking it down into these recursive layers. Then, it applies these special transformations to each layer, kind of like carefully turning the tumblers in a super complex lock. And this process continues layer by layer until the exact roots, the solution, just emerge, pulled directly from the polynomial's own coefficients. It's like the equation itself holds the key to its own solution.
So, if this claim holds up, if it survives the intense scrutiny of the global math community, what does it all mean? Are we looking at a new era for algebra? Because honestly, the implications are, well, they're massive.
And this is a really important point. The claim isn't that Abel's theorem was wrong. Not at all. The idea is that it was incomplete. Think of it this way. Abel's theorem was a perfect statement about the limits of the tools they had back in the 19th century. It wasn't some final universal law of mathematics for all time. It was a boundary marker. And the claim here is that someone has just built a whole new set of tools.
And that really brings us to this quote, which just hits the nail on the head. This discovery does more than solve an equation, it redefines what it means to solve. This is so much bigger than just one problem. If this holds, it could literally redefine what the word solve even means in the world of algebra.
So, what could the future look like? The people behind this work are talking about a rebirth of algebraic solvability, a completely new paradigm. It's built on this beautiful idea that every single equation, no matter how ridiculously complex it seems, actually contains the blueprint for its own exact solution right inside of it. The takeaway? No polynomial degree is ever truly beyond our reach.
Which leaves us with this incredible, mind-bending question to chew on. If a 200-year-old impossibility can be challenged like this, what else is out there? What other walls that we think are solid are just waiting for the right person with a new idea to come along and show us they were never really there in the first place?